Thanks, everybody. My name is Carlos Bernardos. I work at UC3M. I'm going to do a short presentation on deterministic networking for connected industry applications that we are performing in the framework of one of the 60 data-driven projects, namely 60 data-driven 04 project. So this is the outline of my presentation. I will first introduce very briefly what deterministic networking is or what deterministic communications are. Then I will go into one specific use case that is very relevant for the 60 data-driven project, that is why we need deterministic networking for industrial applications. Then I will go back a bit to high level again to explain what is the IETF doing regarding deterministic networking in terms of protocols and new specifications. And then I will focus on the challenges, the gaps that IETF is currently addressing or potentially addressing in the future. Some of them are being addressed, some of them may be addressed in the future, that are being tackled by the 60 data-driven project. So let's go first to the introduction. So deterministic communication. So the idea here is try to basically transfer or make the packets arrive at the right time, the right packet at the right moment, okay? So this is what we call deterministic packet delivery. So we should try to guarantee that the packet arrives at the intended destination at a time window that may be smaller or bigger depending on the requirements, without any loss or delay due to any condition of the network. So basically, as we can see in the figure, we have this time window, and we should try to ensure that all or most of them, again, depending on the requirements of the application, arrive at that given time window. There are some efforts being done on this area of deterministic communications in TSN at layer 2, mainly dealing with bridging and these type of things for many type of applications, audio, real-time control for some wire applications. And also in the IETF, kind of more recently, the deterministic networking working group started working at layer 3 mechanisms for deterministic communications. And even more recently, there was a working group that now is closed that was called RAW, Reliable Available Wireless, that was focusing on the deterministic communication aspects for wireless heterogeneous multi-hop networks. Now the working group is closed because basically after doing an initial phase of work where they were looking into the problem statement, the use cases, and the overall architecture, the work has come or has been merged again into the DetNet working group. What was the original idea? The idea was at the beginning, let's try to do a standalone working group so they can advance faster, but then move it back to the DetNet working group. So that's one of the reasons you will see in the presentation RAW sometimes, DetNet sometimes, but basically even at the DetNet working group now, they typically have a session devoted to RAW, and they still talk about RAW, although everything is the same. So the IETF DetNet working group was focusing on these layer 3 mechanisms to provide bounded latency and reliability, and also coordinating with other efforts that are being done in other SDOs regarding deterministic communications. If you want to have more information, take a look at the documents. This is the link of the IETF working group page. Then if we focus on one specific use case, this is the one for industrial applications. So in industrial application, industrial environments, there is the need for deterministic networking. And of course, there is the need in many scenarios for wireless. Typically, so far, there has been a lot of proprietary solutions for specific problems. And the idea is to move towards more generic solutions, also involving, for example, 5G instead of proprietary solutions. So in an industrial environment, we may have a combination of things like this. So we may have a backbone that is wired, for example, based on Ethernet, and we may have different islands or different wireless technologies that require deterministic capabilities. We may have Wi-Fi based solutions, we may have 15.4 solutions, and we may have also 5G network solutions. So the idea is to guarantee that in these scenarios we have deterministic guarantees or characteristics between end-to-end flows for traffic that requires that, like for example PLC type of traffic, but also coexisting with traffic that doesn't require this type of guarantees like best effort. So the idea is that the solutions should be or must be able to cope with different types of requirements coexisting on the same network infrastructure. That's an important requirement for an industrial scenario and for many others, where not all the traffic require deterministic capabilities. Then, having this into, or considering this, the ATF DetNet RAW, the wireless DetNet, has an architecture conceptual model that is being finalized as of today, still not published as a standard, but being finalized, and it's something along these lines. So we have, on the one hand, on the data plane, we have different raw nodes, different nodes that are providing some that they are doing some things to provide these end-to-end deterministic capabilities between one node that is connected to an ingress end node and one node that is connected to the other egress or ingress end node. It may be also the case that the endpoint is also a raw node. That's also supported. And it's also supported that there may be some no raw enabled nodes in the middle. Of course, the type of guarantees will be different depending on the scenario. In connected to this data plane scenario where we may have wire and wireless links, we have the control plane entities. And in the case of RAW, basically, these control plane functions, they are in the shape of, for example, path computation elements that are capable of computing all the possible paths between one endpoint and another endpoint. And these potential paths are then used by another entity that we will see later on real time to decide which path each packet has to traverse to guarantee or to provide the guarantees required for the deterministic network. So going into a different view, that will be what we have in a raw node. So we have, for example, OIM mechanisms. So we have to be able to measure and monitor what is happening in the network at different levels and use that information for these very fast decisions of the available paths that can be used, that are called tracks, and decide which track to use for each single packet or which tracks to use for each single packet, because we can do things like duplicating and merging packets to enhance reliability. So we may have paths that follow or packets that follow different paths at the same time. And we have, that will be the job of this Pareo actuator that stands for Packet Hybrid Queue Replication, Elimination, and Ordering. We have the OEM entities, and we have this PSC path selection engine that actually is now changing names in the latest evolution of the standard. But the idea, regardless of the name, is that this is the entity that is deciding which actions to take on each single packet that arrives at the node. Okay, so this is operating as a faster time scale as compared to the PCE, the path computation element, that is basically having a look of all the potential paths that are available. And this PSC may be something that is centralized. It may reside on the ingress node typically, or even on a node outside of a raw network, or it may be distributed and residing on every single node of the network. That's depending on the model. Then, considering this, we have different challenges that are being addressed by the 6D data-driven project in collaboration with also some of the work is being done in collaboration with the Predict 6D European project. So one of the things that we are looking at is into multi-domain extensions. So the DetNet model currently, although it's not meant to be like that, it's not meant to be only supporting single administrative domains. So far, the solutions that have been considered are monodomain. Okay, although the architecture, the overall architecture, already considers multiple domains. This is from an RC describing the overall architecture. But we need to do things to enable this, especially if we consider wireless environments or wireless scenarios. For example, in this figure we have, I will not go into the details, just an overview of the problem, different domains, administrative domains that may be connected via wireless or wired networks. And on each of these domains, we may have a path computation element computing the possible paths, and then the PSCs, the path selection engines, again, depending on this router centralized model, taking decisions. So we need to have something that coordinates the PCEs and the PSCs of different domains. And coordinating this involves even discovering that there is another domain, that there are those entities, that there are these potential entry points on the other domain. All these type of things need to be addressed, need to be developed. Also involving ONDM mechanisms that are capable of somehow being able to monitor and measure some metrics of end-to-end connectivity traversing multiple nodes. So that's one of the challenges. Another challenge that we are looking at is how to integrate raw and edge computing. Why this is relevant? Well, in edge computing, in a MEC, multi-access edge computing, this is the architecture. I will not go into the details, but typically you want to have applications that are running on the edge to obtain different advantages. One of the easiest one to see is delay. Since we are executing things closer to the end user, delay is shorter. But the connection between the actual consumer of the application, the terminal device, and the edge host where this application is, or part of this application is being running, that may be connected via a raw network. And there is so far no way to guarantee this integration between the MEC architecture and the potential transport network that connects the MEC architecture, the MEC platform, and the end user. And this is what we are trying to do, basically by extending this NP2 reference point of the MEC architecture. Again, I don't have time to explain all the reference points, but the idea is to extend this that is not detailed to ensure that by having this logical entity on the MEC platform, the raw controller, we can interact, and from the edge, we can instruct the network to provide some guarantees for the connectivity between the edge platform and the final user consuming the service. And that allows us also to do adaptation at the edge platform, at the edge service, based on the conditions of the network, and also prepare for some potential migration of applications to another MEC host based on the requirements of the application and the conditions of the network. And the last challenge that we consider is mobility. Of course, in wired scenarios, mobility is not such a problem because you are not expected to move. But in wireless, mobility is a potential situation that you may have to cope with. So you may need to pre-configure tracks in advance prior to movement to guarantee the characteristics in terms of determinism when you have moved. You may need to compute where to move considering the requirements of the application in terms of determinism, and then the mobility candidates may be different as compared to the traditional mobility problems because you have to consider determinism that is beyond that point of attachment connected to the other endpoint. So you have many different things, and again, this may require to do some signaling between path selection engines, the PCE, and this type of thing. So that's the other main challenge that we are tackling in this project. And just to finalize, as a kind of conclusion, just a list of the contributions that we have been doing to the ITF, which, as you can see, are quite some. And I'm highlighting here in this box the ones that are adopted. Some of them are already published, so we were the main editor of the use cases document. That's already published as an RC. We were contributing to the OIM part with all these challenges, being sure that this is considered there. This is already published. We are part of the editorial team of the controller plane framework, again, ensuring that the multi-domain, for example, is present there. So the requirements for that framework should consider this. And we are also now part of the editorial team of the requirements for the industrial wireless applications. So what I mentioned before about the scenario. And then some individual submissions, meaning that they are not yet adopted, but are being discussed on each of the main challenges that I've summarized before. The multi-domain, the edge integration, and the mobility part. And with that, I conclude my presentation. Thank you very much. So you have any questions? Yes?
Thank you, Carlos. Is there, I have seen that the multi-domain extensions, basically the draft you are discussing is the one that you have. Is there any other industrial push toward the multi-domain?
No, in the form of a draft in the ITF, but when I presented this, one of the feedback I got from the chairs is that this should not only consider the wireless part, but also the wired part. So they were interested in looking into this, and the main feedback was, this is an interesting piece of work, but try to ensure that it's generic enough to potentially cover also connection of wired domains. So there is interest, but not in the way of a draft yet.
And what technology is this including?
Which one? The one I'm driving is kind of generic as the ATF is layer 3. So we are considering the framework of DetNet. You know that there are different data planes that can be used, MPLS over IP, all these type of things. So it's generic. We are basically at this point, what we are doing is ensuring that at the control plane, we have the right tools to ensure that we can establish everything over multiple domains, but we are not depending on a specific layer 2 technology. Vincent?
If I understand correctly, you are using this MP2 interface in order to convey some specification from one domain. Is that correct?
The MP2 part is on the edge. So the MP2 part is one of the reference points in edge to basically explain. Let me maybe go to this. How can I go here? So the MP2, as is included here, is a reference point to instruct how to configure the data plane that is used between the MEC host and the user. And in this case, we are assuming that this data plane is raw capable, so has some ways of configuring this, so for this type of scenarios. So the idea here is that we have the intelligence required to this node configure the raw network in the way that is required for the requirements of the traffic.
Okay, so you take for granted that
what I take from red thread is, in case you have a raw capable domain, yeah, what you need to do. Because of course, if you don't have a raw capable domain, you cannot do anything. But the idea is that without this extension, even if you have a raw capable domain, you will not have any way of putting it.
Discover whether
Yes. There are things that by having this raw PSC that is aware of MEC, you can make them basically discover and do these things. Okay. Thanks. Any more?
Yeah, dealing with a very important subject, right?
Of course, if you ask me, everything I'm dealing with is a very important, interesting.
The gaps between the domain in order to have deterministic.
Yeah. So I think that this particular scenario is relevant in the sense that typically you need MEC, you need edge in many scenarios where you need latency, low latency. And there are many use cases where you have high reliability requirements and you rely on also edge computing for doing things. So I believe that there is an important gap here to cover.
The MP2 interface gives you some margin for
the MP2, yes, is in edge in MEC. This is not fully detailed, so you have the freedom of doing this type of thing. So we are leveraging that there is this reference point described, but not fully standardized, so you can put things there. That's the idea. Okay, thank you very much.